enough. So I'm going to show you guys a couple of tricks as you're going through these. And the tricks that I show you as far as what the problems look like to start with is what I'm going to try and do with it. So this one I have secant over cosine minus secant times cosine. So in this case right away, what I'm going to do is I notice that I have secants and cosines and they're inverses of one another. So I know that if I take the left part of this, if I just leave this for right now, I get 1 over minus 1 over cosine times cosine over 1. So this portion of the problem equals what? 1. Okay. So I have secant over cosine minus 1. Now I'm going to take that. Excuse me. I'm going to take this and I'm going to rewrite secant in terms of cosine. In doing so, I get the following. 1 over cosine times 1 over cosine. I'm taking this fraction and turning it into that. Everybody okay with that? Yeah. Therefore, I'm going to get 1 over cosine squared minus 1. Yeah?
Are you multiplying cosine and cosine?
What I'm doing is the secant part can be rewritten as 1 over cosine. It's being multiplied by a 1 over cosine. That when it's in the denominator, it's a 1 over cosine already in the denominator. Okay. Same change, flip. So there's two things. I'm changing it into a cosine. Okay. Yes, ma'am.
So you only are trying to turn secant, cosine, and cotangent into sine, cosecant, and tangent. You're trying to turn the three inverse.
Yeah. A lot of times it's easier to switch into the cosines and sines because sometimes it's clearer to see what you're doing.
Okay, but you don't have to.
No, there's more than one way to do this. And right now, I just realized that I could have done something different.
No, but what I was saying is, I don't know, I got really confused and I started switching to cosine to secant.
Oh, and that's okay because look at what I'm seeing right now is everybody see I have 1 over cosine squared. 1 over cosine squared is what? Secant squared, which I could have done right away because secant squared minus 1 is tangent squared. So there's 2 ways I can do this. I could have gone through this the long way and done a, common denominator and multiply through, or realize right away that this is secant squared minus 1 by taking the cosine and bringing it back up top. Knowing the Pythagorean identities, 1 plus tangent squared is secant squared. Well, if I get tangent squared by itself, that's what I have right there. So the answer is tangent squared. Okay.
Did you do 24?
That's number 12.
Yeah,
was that?
24.
That was 24.
What's that?
This was 12.
Guys, I can't hear him. What's that?
There's only so many problems you can do,
Right.
so they're just going to repeat themselves.
A lot of times, yeah. And that's the idea, because you're right, there's only so many of them that are out there, and as you get into the patterns don't change, but just like a sine and a cosine might flip-flop, and you still do the same process.
80-40.
I'm getting there, I'll get it.
Okay, I just don't.
So 12 was that one. The next one you guys had to do was 16, right?
Yeah.
That was easy.
Yeah.
Yeah.
Secant squared.
Okay.
Okay.
20 was easy.
20. Easy. 20 was easy?
It's tangent.
20 was tangent, okay. Everybody okay with 20?
Yes.
No? Okay. So we have 1 minus cosine squared over sine cosine. 1 minus cosine squared is part of the Pythagorean identity. If I move the cosine over, I get sine squared is 1 minus cosine squared. So I rewrite the numerator, I get sine squared over sine cosine, what drops? One sine. And therefore you get tangent. Okay? Senor. I'm getting there.
24. I just know what to do with the bottom part of
Just did this one. Grab the wrong notepad.
So, I'm trying
All right. What is secant squared minus 1?
tangent squared.
Bless you. Tangent squared. So I'm going to rewrite this as tangent squared over secant plus 1 plus 1. Okay? Now, if I need to get rid of, if I want to add these two together, I have to have a common denominator. The 1 has, bless you, has a denominator of 1. So I'm going to make the common denominator as secant plus 1. You okay with that?
Why do you just have a plus 1?
Because that's what started with the problem.
Why don't you just add?
Oh,
What?
Never, keep going.
So I'm going to create a common denominator as secant plus 1. Okay? Fraction on the left has it. So it's just tangent squared. Fraction on the right doesn't. So it's going to be 1 times secant plus 1. Now, at this point in time, I have to distribute the 1, which is no big deal. I just get secant plus 1. But now I have secants and tangent squares, and those don't really coexist very well. So that meant that I did not need to convert secant squared into a tangent. See how that works? If I go back to what we started with, we started with the secant squared minus 1. Automatically, we converted it to tangent squared because we thought maybe it would help us with something. All right. In this case, if I go back to the original where it was secant squared minus 1, I have everything in terms of secants. Watch what happens. You okay with that? Combine your like terms in the numerator, what do you get? Secant squared plus secant. What's the GCF of secant squared and secant? Factor it out.
problem.
What drops?
Yo, no way.
Secant.
No way.
What?
I got it right. Not sure how. but I got
Over
it
where?
right.
Here?
That's like one time we.
No, because of all of these. Once you get it as a term, once you show it as two separate parts being multiplied together, think of that as a term. Think of it as x plus 1 in the denominator. Yes, sir? Think of this as, this part here was x squared minus 1 plus x plus 1. And I got x squared plus x.
How did you get this?
How would I get this one?
No, the other one.
This one?
Yeah, how did you get that?
Common denominator. Shh, guys, common denominator. Secant squared plus 1 and a secant, and excuse me, and a 1. Bless you. Fraction on the left had it, fraction on the right didn't.
You mean like, oh.
Fraction.
Okay.
These are basically the same problems as x over x minus 1 plus 2 over 1, where you get common denominators. It's the same setup. Instead of an x, you have a tangent. You have a secant. That's the only thing. Instead of one-lettered variables, it's 3-lettered. That's really all it is. treat it the exact same way.
Okay.
Okay. That was 24. What's next then? 28?
28 was cropped out.
Yeah.
32. Verify. Show that it equals secant squared. So when you do this, distribute. Okay, distribute. You get sine squared times cosecant squared plus sine squared times secant squared.
Okay.
What's sine squared times cosecant squared? 1. They're reciprocals of each other.
Oh, okay.
Remember, it's sine. So you get 1.
Makes sense.
This part, you get sine squared over cosine squared, which is tangent squared, which is Pythagorean identity, secant squared.
You get sine squared over
Those
cosine.
Pythagorean identity things are getting this
What's
Why'd
that?
you get sine squared over cosine squared?
Yeah. Oh, secant.
Secant squared.
cosine, all right.
Secant is 1 over cosine.
Oh.
Sine times 1 over cosine squared is sine squared over
I,
cosine
got it.
squared.
I have a feeling it's just gonna like come to me. Like it's just gonna randomly.
And I'm not gonna lie, it's the Pythagorean identities that you guys have to know. You have to know these. Okay? You've got to know those. Oh. 36. Okay. Why not? Because you're happy. This is a very, very common setup. Notice how you're starting with addition, and then it wants you to show multiplication. Really, the only way to show that that works is to use common denominators to combine like terms, to multiply across. That's really the only way that this problem can be done. So automatically, rewrite secant and cosecant in terms of sines and cosines. Secant squared is 1 over cosine squared. Cosecant squared is 1 over sine squared. What's going to be the common denominator between those two?
Cosine.
Cosine squared, sine squared.
Yeah.
Fraction on the left needs a
Sine.
fraction on the right needs a. What's your numerator become? 1. And look what happens. Is it 1 over cosine, 1 over sine? Reciprocal properties? Flip them.
Wait, why numerator 1?
Yeah. Yeah.
Huh?
Oh.
Whoa.
That's not on the sheet. It is?
The bottom left.
Oh. Hey.
Oh, that bottom left corner.
What's up?
See, I had writing below it.
Ah, there you are.
I was just looking at that one.
Then you just flip it and you all of a sudden you get secant, cosecant, or secant squared, cosecant squared. Excuse me. That is a hugely common setup. Very, very common. You see this one written with sine squared, or not sine squared. You'll see it with cotangent, tangent. They do it all the time. It's a very, very fast way of doing one of these.
I don't like that problem. I don't like that.
Okay. 40.
Wouldn't that already be verified?
What?
Like the original problem.
No,
Why?
because it says secant plus cosecant.
Oh, okay.
It's not.
Why did that work?
I didn't see it. My bad. You're right. I'm wrong. So we're good. Whoa.
A plus sign.
I got it.
Nope, it's a multiply.
Thanks, Ms. Murphy, for clarifying that.
Again, it's a plus sign.
Yeah, are you having fun?
We can do it.
Multiply. It's just fun.
Can we do anything else? Is that it?
No. All right, secant minus cosine all over tangent squared. Yesterday we had talked about one of the tricks that when you have two parts in the numerator with subtraction, addition, or something like that, and only one part in the denominator, a lot of times, yeah, split them apart. Split them apart and deal with them independently of one another. Sometimes it's helpful. Okay? So you're going to get secant over tangent squared minus cosine over tangent squared. You okay with that?
Yeah.
Now, I'm going to work with both those fractions independently of one another and rewrite them in terms of just sines and cosines. So, secant rewritten as cosine is what? 1 over cosine. So I'm going to do this as 1 over cosine. And now tangent squared in terms of sines and cosines is what? Sine squared over cosine squared. So I'm dividing by sine squared cosine squared. Which means I'm going to flip them.
Flip them.
Okay, everybody all right with that?
Yeah.
Yeah.
So now I have 1 over cosine times cosine squared over sine squared.
Cosine.
So far, so good?
Yeah.
Okay. So now, the fraction here on the left, move this up some, cosine drops, and we get a cosine over sine squared. I'm going to do the same basic stuff with the other fraction. Go back up here. Cosine is already written as cosine. Tangent squared is not. So I'm going to split them apart. I'm going to have cosine over 1 divided by sine squared cosine squared. Now, if you want to go ahead and automatically rewrite it as multiplying by the reciprocal as you start with that, by all means, go for it. I don't mind showing the extra step to make sure that I don't forget. Okay. So now I multiply it out. I get cosine times cosine squared over sine squared, which gives me a new numerator of cosine cubed over sine squared. So far, so good?
There's no typing.
Almost. Almost. I have the same denominator now, don't I?
Yeah.
Put them back together with the denominator. Numerator has two parts, they have something in common. What do they have in common? Factor 1 cosine out.
This long.
And 1 minus cosine.
1 minus cosine squared is sine squared.
This is so frustrating.
It's cosine.
The answer is going to be cosine.
That's it. You know, these problems are
Love
frustrating.
cosine.
Problems are frustrating.
It's a logic puzzle.
So,
It's a logic puzzle.
Yes, and if you're bad at logic puzzles, this sucks.
No. You'll get better.
Oh,
It's the first day you ever seen these before. It takes time.
it's like, oh,
You're not going to be a pro at it right away.
I wish I.
You know, this is simple, like.
I think out of all the ones, I think 44 might have been the nastiest. Yep.
Not even just to-
I got it. 1, over sine times cosine times cosine.
Did anybody think they got 44?
No.
No.
I don't think so.
I didn't even attempt it because I know
We should shower her answers all the same time.
Yes. 1, 2, 3, go.
No.
1 plus cosecant over secant squared. I don't think that's right.
1 over sine times
1 plus what
cosine
was it?
times cosine.
Cosecant over secant squared. I don't think
1
that's
plus
right.
cosecant over secant squared. So 1 plus all over secant squared?
Yeah.
I got blank.
I got no.
Yeah, no. I don't think that'll go get you anywhere. All right. So
1 for 7.
take a look at the numerator. The numerator here has two inverse functions, two reciprocal properties. Are we okay with that?
Yes.
So what I'm going to do is I'm going to rewrite this into sines and cosines and create a complex fraction.
Oh.
Secant plus cosecant, oops, is 1 over cosine plus 1 over sine. We okay with that?
Yes.
What's the common denominator? For the numerator, I'm just looking at the numerator here. Let's get to the common, I'm just working.
Cosine.
Cosine.
Cosine sine. So if I get a common denominator here, I'm going to get cosine, sine, and up top it's going to be sine plus cosine.
Okay.
Okay. Do the same thing in terms of sines and cosines with the tangent. Tangent's what over what?
Cosine and sine together is sake.
Cosine over.
What?
Cosine and sine.
The denominator
Spelled cosine.
also needs something common. What's going to be common between the 1 and the cosine? Cosine. Fraction on the left needs a
Cosine.
fraction on the right doesn't. Now I just have a complex fraction. Rewrite it horizontally.
Alright. This is just the numerator, but yeah, just the numerator.
When you divide fractions, you actually multiply by their
Reciprocal.
We can't do what we want to do on paper, so.
so I multiply by the reciprocal.
Okay.
Makes sense.
What drops?
Everything except for the sine.
Cosine.
Sine plus cosine.
The
And a cosine.
1 over sine.
Good, I'm glad you said 1 over, because it's not wearing a flotation device. And what's 1 over sine?
Figured it out. Dang it! I would have left 1 over sine. I would have gotten points off.
I was actually close.
You had a cosecant in it, so
Yes.
you
Yeah, I
know.
was pretty close.
Close only counts in horseshoes and hand grenades.
Yeah.
And what is that?
What? You ever played horseshoes before?
Is that the one that's like?
I don't-
like a
It's so you're throwing a horseshoe.
Yeah.
I don't
Yes.
even, I don't
Half
even
game,
know
yes.
how to play.
Oh, and then
You-
yeah.
like-
Hand grenade. If you hit somewhere in the neighborhood, it
You're supposed
works.
to hit me.
Okay,
Hit
yeah.
me.
I'd be.
Yeah.
I understand not playing with grenades.
Right, yeah.
Grenades.
I played horseshoes with grenades.
How'd you get that plus in between cosine and sine on the one that's flipped? Wasn't it like, weren't they like
Here?
multiplied?
I got a common denominator with this.
Yeah.
1 plus cosine, the common denominator is cosine. Fraction on the left needed a cosine. Fraction on the right already had one below it.
What about? Oh, alright, yeah.
It would help if it's one by actually read this.
What's that?
Could we maybe write it so we can read this fraction?
Who's trying to say Kobe?
Jerk. I'm not a jerk.
Yes, you are.
I'm not.
Everyone else can read it perfectly fine.
That's nice and soft.
It says Roz
Nice
over Roz.
Squint, you'll be fine.
Sock over nice sock.
All right, let me show you some other trick ones.
Are we doing the same stuff? Just
Yeah, I'm going to show you 38.
Leave me alone.
Well then. Wow. I can do this.
Okay. You have three terms: cosine squared, tangent squared, plus sine squared, tangent squared, plus 1. And it has to show that it equals secant squared. So this one looks pretty nasty.
Probably not. And you just cancel everything.
Okay.
I've got it.
So you start.
You get rid of the 1.
Cosine squared times sine squared over cosine squared plus sine squared times sine squared over cosine squared is 1. All I did there was what?
You just
Change the
put
sines and
sine
cosines. Excuse me.
Yes.
Alright, nice.
Okay.
Got it. That's it.
Yeah, hey, you're done. It equals secant squared. Yay, go to the next problem. All right. One could wish, right? So, obviously you have 3 parts now, which means you probably want to find a denominator. Okay. So let's see what we get.
Can we get rid of that 1?
I don't know what's going to get. It's not going to do anything. But what's going to be the common denominator for all 3 of these?
Wait, you should get rid of it.
Okay. So now you have what? Sine squared, cosine squared, plus sine squared, sine squared. So you have all that.
Wait.
What is it?
Oh, you gotta get.
What did the 1 turn into?
Yeah.
Turned into a
I
cosine.
forgot the 1 was part of it.
Yes.
Because cosine squared times 1 is cosine squared. Well,
Cosine squared.
I think.
I think.
Sine
We just call it a day.
Hey, sine squared plus cosine squared is 1.
And then the other one.
Ah, careful though.
Dang it. Okay, they're connected, yeah.
They're addition. You gotta find a common.
Mr.
Well-
Tuna, how you doing?
Hi, Juno, what's up?
Nothing.
You want to yell at anybody?
No, I was thinking about you.
Go ahead.
I'm thinking about issuing tickets to the teachers who are playing loud music in the school.
Oh yeah. It wasn't me.
Ah. All right, Mr. Marcy.
All right.
It wasn't me. I didn't do it. All right. So I didn't see it, but it's not going to really get you anywhere though when you go to sign in the 4th here.
Yeah,
What?
I'm just throwing ideas.
I know.
Sine
Sine
squared.
squared,
Sine
sine
squared.
Oh, okay, we're good.
That's where I'm going.
Well,
That's where my brain goes.
All right.
It's just nice.
Is that getting you anywhere though?
No, but it's nice.
Yeah, I don't think it is.
I do.
That 4 intimidates me.
Then you could just.
Okay. All right, so if you separate them again, see what happens. I don't know.
Something could change, you never know.
Yeah, you never know.
Get you want to break this out.
Depending on whether this actually has an answer.
Well, it does. It has to equal secant squared, right? At some point in time.
That's so.
Sooner or later, we should get there.
All you do is get 1
Okay.
plus cotangent. Oh, wait.
Isn't it tan? Sine
Well, let's see what happens if you simplify each individual. Hey, look, we're back to 1. But sine squared plus 1 doesn't get you there. Now here you get sorry, so it's tan squared, sine squared.
Yeah.
I think we just start this problem over.
I said
Why did I get that? I have a sine squared over a sine to the 4th over cosine squared. If I go back to the idea that this was a sine squared over cosine squared, I can simplify one of that grouping as tangent squared.
yes.
I can only undo that multiplication. Let's see. I still have one there. I didn't write it down.
Do you even know how to do that?
So you do 38.
If you did, I'm like,
I was gonna laugh if I did that. I was gonna cry.
Equals maybe
28, is it?
maybe you change it to the wrong answer.
Well,
Just to mess with us. Just to see how long we can go.
Wait, why did you cross
That'd be hilarious. I'd do that.
cross what out?
Find the
on
answer.
the sheet?
That's what I'm trying to remember. Did I write that wrong?
feel like you crossed it off. Oh, wait.
Maybe you meant
Thank you.
cosecant squared.
You might. Who probably was it?
It looks like cotangent squared.
What's up?
How did you get sine squared, sine squared over cosine squared, tan squared?
Because the sine squared over cosine squared becomes tan, and then tan times sine squared.
And
Just making stuff up.
Let's go to different. Wait, I think I wrote it down wrong. I think I crossed off the wrong part of it. I think it's supposed to equal something else. That's why I'm getting the wrong spot. Let me show you the other trick though. We'll go back to this one. I gotta relook that one up. I am serious, this is funny. Watch this. This is easier.
Are you sure?
I honestly think that I think you're right. It's probably supposed to be cosecant. I'm going the wrong direction for that. I gotta find this the original of this thing. So, and you know what I probably did? I bet you anything. I just started the problem wrong, and it probably takes 2 steps, and I just have a brain fart going right now. So this is a top tip learning point for you. If you get to the point where you have no idea what you're doing anymore, go to the next problem.
don't keep going.
No. All right, so then.
Gotta grind something, finish
That's what I
it.
did on my
I
project.
never
It's
quit.
30%.
Yeah, well, I would be proud of that. Is the first term a perfect square? What?
Yeah.
Yeah.
Is the second term a perfect square?
Yeah.
Is that a subtraction symbol?
Yeah.
So it's a difference of squares, isn't it? This breaks you into cosine squared minus sine squared times cosine squared plus sine squared. What's cosine squared plus sine squared?
1.
1.
I remember this time.
Yay.
Check.
Because it worked.
I got it, don't worry.
You see stuff like that a lot. See the difference of squares shows up all the time.
I don't know why.
Wait, where did the other part?
We don't need it.
It's 48.
I see what you did.
Don't kill puppies.
I see what you did there.
Don't kill. I'm sick of your comments. Please keep them to yourself. It does nothing for the group of us. Foil it out. It's a big thing that happens with you guys a lot when you get to something where it's junk squared. You forget to foil it out correctly. Think of it as tangents 1 plus x, 1 squared plus 2x plus x squared when you foil everything through. So you get 1 plus 2 tangent plus tangent squared. On the other one's the same idea. 1, now it's minus 2 tangent plus tangent squared.
Got 2.
When you foil it out,
Oh, I know, but like, okay, I already,
well, look what happened to 2 tangents.
they just go away.
They go away. Okay? So we have 2 plus 2 tangent squared now. What do they have in common?
2.
2. And what is 1 plus tangent squared?
Oh,
So you can see this.
secant squared. So just a little bit later.
Wanted to show you that one because it happens all the time. You guys will forget you'll forget that middle term. Okay, when you foil stuff through. Okay, don't forget the middle term.
Wait, so 2 plus tangent squared, you simplify that into 2. 1.
Common denominator.
Oh.
I'm not common denominator, sorry, GCF, they both have a 2 in common. I pull it out, so I get 1 plus tangent squared.
Yeah, okay, I got it.
That's all, I was just doing GCFs.
All right.
Just pulling GCFs. I'm trying to pick ones that will help you later. Let's try 46. What are you going to do? Common denominator. Very good. Start with your common denominator. Write out the common denominator. Fraction on the left needs a
1 plus cos all the time.
Sign.
Wait,
1 plus
nothing. Nothing.
No, it needs a sign. It
Needs a 1 plus cosine.
It
it has a 1 plus cosine. It needs a
sign.
fraction on the right needs a 1 plus cosine. So you have to FOIL that out. It's going to be quantity 1 plus cosine, quantity squared. So you're going to get 1 plus 2 cosine plus cosine squared. Look at just the numerator. What do you get? Combine your like terms. What do you get? What can you simplify?
Sine squared plus cosine.
What does that equal?
1.
What's 1 plus 1?
2.
So your numerator becomes yes, sir. Yeah, it's supposed to only look at one. Okay.
So now,
Cross out.
To your GCF again. GCFs come back.
two overs,
Otherwise known as.
what? Two overs, one.
2 over sine, otherwise known as.
Very good.
Okay.
Over sine, multiply, bring it up, comes cos again. Okay. I'll figure out what I did wrong on 38 and show you guys that. I have a feeling I know what I did. I'll go back to it. So let's see here. What I want you guys to try tonight. Let's go through.
Same worksheet, but
Yeah, same stuff. Try those. Okay. To be honest with you, most of them have an example that we've already done. Most of them already have an example that we've done. There might be 2 of them that we have not. But you should be all right. Don't forget the tricks. When you have stuff that are all inverse properties and stuff, rewrite them in terms of domains. When you have addition turning into multiplication, it meant there had been common denominators. Difference of squares. Little things like that. We'll do those for tomorrow. I'll figure out what I did. I did something stupid on 38. I know I did something stupid.
Why should it be like a Tuesday?
It probably is a 2-step thing. I've already just brain farted.
We overthought it.
This is fantastic. Oh, watch this. So it's cosine squared, tangent squared. I'm an idiot. So if I'm looking at just this grouping here, what do they have in common? What's cosine squared plus sine squared? 1. So you get tangent squared times 1 plus 1. What's tangent squared plus 1? 2 steps.
Wait.
Secant squared. So it was supposed to be secant squared.
Wait, how do you get 1 again?
Cosine squared plus sine squared.
Oh, okay.
So tangent squared times 1 is tangent squared.
But I thought the cos was up
If you
there.
would've kept going the other way, we would've been.
I probably would have gotten there eventually by pain and suffering and whatnot.
No, how's the chemistry?
Yeah, 2 steps. Look at that. Oh well.
Special?